The cosmos whispers secrets in a language of pure geometry. Across the vast expanse of space and time, from the spiral of a galaxy to the structure of an atom, hidden patterns suggest a deep order to reality. We are about to journey through 30 mind-bending theories that decode this cosmic cipher, revealing a universe far more interconnected and mysterious than we ever imagined. You will discover the mathematical fingerprints left on creation itself, from ancient sequences governing flower petals to anomalies in the echo of the Big Bang. What if the alignment of distant quasars points to a universal handedness we cannot yet see? Could it be that our entire reality is a holographic projection from the edge of space? What hidden order do you suspect lies behind the chaos of the stars, this sequence of numbers, 1, 1, 2, 3, 5, 8, and so on, is far more than a mathematical curiosity. It is a signature. You can find it in the gentle spiral of a sunflower's seeds, each new seed positioned at a precise angle to the last, maximizing space and sunlight in a perfect Fibonacci spiral. It dictates the arrangement of leaves on a stem and the unfurling petals of a rose. Even a humble snail carries this cosmic code on its back, its shell a miniature logarithmic spiral echoing the mathematics of a distant hurricane. But this pattern does not remain on our planet. When we pull back our view to the cosmic scale, we see the same spiral form etched across the heavens. Spiral galaxies like our own Milky Way whirl through the void, their majestic arms tracing out the very same geometry found in the shell on the beach. This is not a mere coincidence. It suggests a fundamental blueprint, a universal rule of growth and organization that operates from the infinitesimally small to the unimaginably large. The Fibonacci sequence appears to be a fundamental rhythm in the universe's method of building things, a hidden pattern of efficiency and beauty woven into the fabric of space, time, and life itself. What does it mean that the same numbers that describe a pinecone also govern the architecture of galaxies? It hints at a deep, underlying order, a language of creation that is both simple and infinitely complex. This same mathematical elegance, however, begins to fray when we look at the universe's oldest baby picture. Just 400,000 years after the Big Bang, the cosmos cooled enough for light to travel freely, creating a fossilized glow that still permeates all of space. This is the cosmic microwave background, a near uniform sea of microwave radiation that is the oldest light we can observe. It is the afterglow of creation itself. By meticulously mapping the tiny temperature fluctuations in this background, cosmologists expected to see a random, isotropic universe, one that looks the same in every direction. This is the cosmological principle, a cornerstone of modern science. But the map revealed something deeply unsettling. The fluctuations are not entirely random. They appear to align along a specific plane in space, a mysterious corridor that scientists have dramatically nicknamed the axis of evil. This is not a malevolent force, but a statistical anomaly that seems to point a finger, suggesting a preferred direction to the cosmos. It is a pattern we were never supposed to see. If the universe truly has no center and no edge, why would its most ancient structures whisper of a hidden axis? This alignment challenges our most fundamental assumption about the universe's symmetry, forcing us to question if we are missing a profound piece of the cosmic puzzle, a secret geometry written into the very first moments of time. This unsettling axis is not the only profound mystery written into our universe's foundation. The very laws of physics themselves appear to be balanced on a razor's edge. consider the fundamental constants, the unchanging numbers that dictate the strength of gravity, the power of the electromagnetic force, and the mass of a single electron. These are not arbitrary values. They are the universe's fixed settings, and their precision is nothing short of breathtaking. If the force of gravity were even slightly stronger, the universe would have collapsed back on itself in a fiery crunch moments after the Big Bang. If it were slightly weaker, no stars or galaxies would have ever condensed from the primordial gas. The same goes for the strong nuclear force that binds atoms together. If its value differed by even a tiny fraction, stars would be unable to forge the carbon and oxygen that are essential for life. They would either produce no heavy elements at all, or they would burn through their fuel in a cosmic flash. We exist in a universe that seems perfectly calibrated for our presence. This incredible fine-tuning has led scientists to propose some of the most mind-expanding theories in all of cosmology. One is the anthropic principle, which suggests that the universe must be compatible with the conscious life that observes it. In a sense, we see the universe as it is because if it were any different, we would not be here to see it. An even more radical idea is the multiverse. This theory proposes that our universe is just one bubble in a vast, frothing cosmic foam of universes, each with its own random set of physical constants. In this infinite tapestry, most universes are sterile and stillborn. We simply happen to live in the one rare bubble where the numbers lined up perfectly to allow for galaxies, planets, and life. Are we the product of a cosmic coincidence? Or is our universe a single, intentional pattern woven into a much grander design? This cosmic fine-tuning extends to the grandest stage of all, the very architecture of existence. When we map the universe on its largest scale, a breathtaking pattern emerges from the darkness. It is not a random scattering of islands, but a vast, intricate web. Billions of galaxies are not isolated. They are strung along immense, thread-like filaments of dark matter, stretching for hundreds of millions of light years. These filaments connect at dense nodes, where enormous clusters of thousands of galaxies swarm together. And between these brilliant strands lie the cosmic voids, unimaginably vast and nearly empty regions of space, so huge that they make our own local group of galaxies feel utterly insignificant. This is the cosmic web, the fundamental skeleton of our universe. To see it is to look at a map of creation itself. The pattern is so delicate and so vast, it resembles a neural network in a cosmic brain, or the frothy structure of a soap bubble universe. This is not what scientists expected from a universe born in a chaotic explosion. The Big Bang should have left behind a far more uniform, lumpy porridge of matter. So what sculpted this intricate cosmic tapestry? The invisible architect appears to be dark matter. This mysterious substance, which does not emit or reflect light, makes up the vast majority of the universe's mass. Its gravity provided the initial scaffolding. In the early universe, tiny ripples in the density of dark matter, echoes from the Big Bang, began to pull ordinary matter inward. Over billions of years, gas and dust flowed along these invisible gravitational highways, coalescing into the galaxies and the brilliant filaments we see today. The cosmic web is a frozen record of that growth, a snapshot of gravity's patient work over cosmic time. It tells us that the universe was not born with this structure, but that it evolved according to a hidden blueprint written in the first moments of time, a blueprint whose primary ingredient remains utterly invisible to us. This search for cosmic architecture finds a curious echo in our own celestial backyard. Centuries ago, astronomers noticed something peculiar about the distances of the planets from the sun. A mathematical relationship, now known as Bode's law, seemed to predict their orbits with uncanny accuracy. The formula was simple. You start with 0, then 3, and double the previous number each time. So the sequence is 0, 3, 6, 12, 24, and so on. Then you add 4 to each number and divide by 10. This yielded a series that almost perfectly matched the average distances of the known planets in astronomical units, where 1 unit is the distance from Earth to the Sun. Mercury fell at 0.4, Venus at 0.7, Earth at 1.0, Mars at 1.6. Then there was a gap at 2.8, a gap that was soon filled with the discovery of the asteroid series. Jupiter and Saturn fit beautifully at 5.2 and 10.0. For a time, it seemed humanity had unlocked a fundamental rule of solar system design. But the pattern broke. The next planet, Uranus, was discovered, and it fit the sequence at 19.6. Yet when astronomers looked for a planet at 38.8, they found Neptune, but it was not where the law predicted. It orbited at 30.1, a significant deviation that shattered the law's perfection. Bode's law was not a fundamental force of nature, but a numerical coincidence born from the process of planetary formation. We now understand that planets coalesce from a swirling disk of gas and dust around a young star. Within this disk, gravitational interactions and the conservation of angular momentum naturally tend to space planets apart in a way that can resemble a rough geometric series. The law was a glimpse of an underlying physical process, a ghost of a pattern in the chaos of creation. Today, as we discover thousands of planets around other stars, we search for new patterns in their orbital spacing, hoping to find a more robust law that reveals the true architectural principles of solar systems across the cosmos. This cosmic preference for a specific direction does not stop with the faint whispers of the cosmic microwave background. It echoes in the furious hearts of the universe's most powerful engines. Quasars are the intensely bright cores of distant galaxies, powered by supermassive black holes feasting on surrounding matter. They are cosmic lighthouses, visible from billions of light years away. When astronomers studied the light from thousands of these quasars, they noticed something that defied all expectation. The rotation axes of these quasars, separated by distances so vast they should have no possible connection, showed a surprising degree of alignment. Their spins seemed to be coordinated, as if choreographed by some unseen force. This is not a small local effect. We are talking about structures billions of light years apart, whose light has been traveling for most of the universe's history, all hinting at a shared cosmic handedness. The principle of isotropy states that the universe, on a large scale, should look the same in every direction with no preferred axis. This discovery of aligned quasars strikes directly at that foundational idea. How could such a coordinated pattern emerge across volumes of space that have never been in causal contact? The light from one quasar has not had time to reach the others since the beginning of time, so they cannot possibly have influenced each other. This suggests the alignment was imprinted at birth, a fossil from the universe's first moments. Perhaps some primordial field, a texture in the fabric of spacetime itself, guided the angular momentum of these infant structures, setting their spin along a preferred cosmic axis. Or maybe it points to something even more profound, a fundamental asymmetry woven into the laws of physics, a hidden directionality to reality that we are only just beginning to perceive. What force could possibly reach across the entire cosmos and leave its signature on the spin of galaxies? This cosmic alignment hints at a reality far stranger than we perceive, one where the very dimensions we experience might be an elaborate illusion. The holographic principle is perhaps one of the most radical ideas to emerge from the frontiers of physics, born from the clash between Einstein's theory of gravity and the bizarre rules of quantum mechanics. It proposes a staggering possibility. The three-dimensional universe we live in, with all its depth and volume, might be a projection, a hologram, encoded on a distant, two-dimensional surface. Think of it like a credit card hologram. The flat, shiny surface contains all the information needed to create the illusion of a three-dimensional image. In the same way, this theory suggests that all the information describing everything within a volume of space, every star, every planet, every one of us, is actually painted on the boundary of that region. For our entire observable universe, that boundary would be the unimaginably far-away surface from which the cosmic microwave background radiation emanates. The world we see and feel would be a kind of cosmic movie screen, and we are the actors living inside the projection. This solves a profound puzzle about black holes. When matter falls into a black hole, what happens to the information it contains? Quantum physics says information can never be truly destroyed. The holographic principle provides an elegant answer. The information is not lost inside the black hole, but is instead perfectly encoded on its two-dimensional event horizon, the point of no return. This hidden pattern of information, written on the edge of space, could be the ultimate source code for reality itself. If true, it means the richness of our three-dimensional world, from the flutter of a butterfly's wing to the spin of a galaxy, is a magnificent illusion generated from a vast, flat, cosmic memory bank. This same principle of recursive patterns, of information encoded at a boundary, finds a stunning visual echo in a different kind of hidden code. Zoom into the jagged edge of a coastline from space. Then zoom in again and again. At every level of magnification, the same degree of complexity and irregularity reappears. This is a fractal and infinitely complex pattern that is self-similar across different scales. It is nature's favorite algorithm for building complexity. You see it in the branching of a tree, where a single twig mimics the shape of the whole canopy. You see it in the forked path of a lightning bolt, in the intricate network of our own veins and arteries, and in the labyrinthine structure of our lungs, which pack a massive surface area into a compact space. These are not perfect geometric shapes like circles or squares. They are rough, fragmented, and infinitely detailed. The most famous of these is the Mandelbrot set, a mathematical object of breathtaking beauty. When you explore its boundary, you find an endless procession of smaller copies of the main shape, each one adorned with its own swirling tendrils and miniature replicas, a universe of infinite complexity generated from a deceptively simple equation. This leads to a profound and controversial question. What if the universe itself is fundamentally fractal? At the quantum scale, the very fabric of spacetime may be a seething, frothing chaos, a fractal landscape of virtual particles popping in and out of existence. As we zoom out, we see matter clumping into stars, then galaxies, then clusters, and finally the vast filaments of the cosmic web. Each level of this structure is not identical, but it echoes the same basic theme of clustering and interconnection. Some cosmologists propose that if we could map all the matter in the observable universe, its distribution would not smooth out into a uniform haze. Instead, it might continue to show this clumpy, self-similar pattern all the way up to the largest possible scales. In such a fractal cosmos, there is no true center and no true edge, just an endless repetition of pattern, a universe within a universe. Are we living inside a natural fractal, an infinite pattern generated by the simple, relentless laws of physics. This endless fractal recursion finds a startling parallel in the grandest cycle of all, the very birth and death of the cosmos itself. While most models see our universe as a one-time event, a singular explosion from nothingness to heat death, one brilliant physicist proposes a far more eternal rhythm. Sir Roger Penrose's conformal cyclic cosmology paints a picture of an endless sequence of universes, which he calls eons. In this breathtaking vision, our universe is not the first, nor will it be the last. Each eon begins with its own Big Bang and expands outward for trillions upon trillions of years, until all matter has decayed and black holes have evaporated. In this cold, dark, and vastly stretched future, the universe becomes smooth and featureless once more. At this point of maximum emptiness, Penrose suggests a mathematical transformation occurs. The end of one eon, stripped of all scale, becomes indistinguishable from the beginning of the next. The death of our universe is, in a very real sense, the Big Bang of the next. It is a cosmic phoenix, perpetually reborn from its own ashes. But how could we possibly find evidence for a universe that existed before our own? Penrose points to the cosmic microwave background, that ancient afterglow. He and his colleagues claim to have found faint, circular patterns imprinted in this radiation, concentric rings where the temperature is slightly more uniform than the surrounding noise. He interprets these as the gravitational shock waves produced by the titanic collisions of supermassive black holes in the previous eon. In his cyclical model, these immense ripples in spacetime would have crossed the boundary between eons, leaving faint, ghostly bruises on the baby picture of our own cosmos. It is as if we are finding fossilized footprints of giants from a time before time, evidence of a cosmos that lived and died long before our own. This is not just a theory of endless cycles. It is a theory of cosmic memory, where each universe carries the faint, geometric echo of its predecessor. Are we living in just one chapter of an infinite cosmic story, forever repeating yet always new? Even the most carefully charted journeys can reveal an unexpected drift. Far beyond the orbits of the planets, two robotic pioneers, 10 and 11, were steadily speeding toward the edge of our solar system. Yet as they sailed through the dark, a tiny, persistent mystery unfolded. Each spacecraft was slowing down just a fraction more than our best gravitational models predicted. This was the Pioneer anomaly, a minuscule deviation, a force equivalent to a mere 10 billionth of the gravity we feel on Earth, gently and inexplicably breaking the probes. For decades, this ghostly tug perplexed scientists. Was it a sign of some hidden mass in the outer solar system? A vast, unseen structure subtly altering their path? Or was it pointing to something far more fundamental, a crack in our understanding of gravity itself? This tiny anomaly fueled investigations into radical ideas like modified Newtonian dynamics, or MEND, a theory proposing that gravity behaves differently at extremely low accelerations, the kind experienced in the deep emptiness between stars. Perhaps Einstein's theory, while overwhelmingly successful, requires a subtle tweak in the vast, quiet realms of interstellar space. Others wondered if the effect was a faint whisper from dark energy, the mysterious force accelerating the expansion of the entire universe, somehow manifesting as a local push or pull on our spacecraft. In the end, the most likely culprit turned out to be something remarkably mundane, yet profoundly instructive. The spacecraft themselves were the source. A careful accounting revealed that heat, radiating unevenly from their nuclear power sources, was providing a tiny, constant thrust in the opposite direction, acting as a gentle brake. The Pioneer anomaly was not a new force of nature, but a testament to the incredible precision of our models and the hidden complexity of our own creations. It taught us a vital lesson. The smallest deviations, the faintest whispers in the data, are often where new patterns hide, forcing us to look deeper, to question our assumptions, and to remember that even a solved mystery can illuminate the path to a greater truth. The smooth expansion of the cosmos might be an illusion. When astronomers measure the light from distant galaxies, they rely on redshift, the stretching of light waves as a galaxy recedes from us. This redshift is the primary evidence for our expanding universe, a cornerstone of modern cosmology. But a small group of researchers has pointed to a deeply controversial pattern in the data. They claim these redshifts are not spread across a smooth, continuous spectrum. Instead, galaxies appear to prefer specific distances, their redshifts clustering around certain values, as if the universe were expanding in distinct, quantized steps. It would be like hearing a receding ambulance siren not as a continuous drop in pitch, but as a series of distinct musical notes. If true, this quantization challenges the very foundation of the Big Bang model, which predicts a smooth and gradual increase in redshift with distance. So what could possibly cause such a startling effect? One radical interpretation suggests that space itself is not a featureless void. Instead, the cosmos may have a subtle cellular or lattice-like structure, a vast, three-dimensional grid of unknown physics. In this view, galaxies would be nestled at the nodes of this cosmic lattice, and their observed redshifts would correspond to these fixed positions, like beads on an invisible string. We would not be living in a smoothly expanding continuum, but within a structured volume with a fundamental graininess to its fabric. This would imply that the universe has a preferred frame of reference, a concept that directly contradicts a key principle of Einstein's relativity. Are we seeing the first hints of a quantum structure to spacetime itself, a hidden architecture that dictates where galaxies can and cannot form? The evidence remains hotly debated, but the very idea forces us to confront a profound possibility. The grand cosmic expansion may not be a simple stretching of space, but something far more strange and structured. Our galaxy is not simply drifting through the void. The Milky Way is on a collision course, racing at over 600 kilometers per second toward a specific point in the constellation Centaurus. For decades, the source of this immense pull was a profound mystery, hidden behind the dense star fields of our own galactic plane. Astronomers named this unseen gravitational monster the Great Attractor. It is a colossal concentration of mass, a galactic supercluster containing tens of thousands of galaxies, with a gravitational pull so powerful it dominates an entire region of space. We are not alone in this journey. Our entire local group of galaxies, and the vast Virgo supercluster it resides within, are all flowing together in a river of stars toward this single point. But the story of our motion is not just about what is pulling us. It is also about what is pushing us. Scientists have discovered that the Great Attractor alone cannot account for the full velocity of our cosmic drift. The complete picture requires another, even more elusive actor, the dipole repeller. Imagine a vast, nearly empty region of space, a cosmic void of staggering proportions. While the Great Attractor pulls us in, this immense emptiness, located in the opposite direction, exerts a different kind of influence. There is so little matter there that its gravitational pull is exceptionally weak. In the grand tug of war of the cosmos, this underdense region creates a kind of push, not through force, but through a lack of it. You are effectively being pushed away from an empty room because the crowded party next door is pulling you in more strongly. This repeller is a void so vast, it makes our local universe feel lopsided. Together, the great attractor and the dipole repeller form a cosmic dipole, a pattern of push and pull that perfectly explains the peculiar velocity of our galaxy. This reveals a universe where motion is not dictated by massive objects alone, but by the intricate balance between the dense nodes of the cosmic web and the profound emptiness of its voids. We are navigating a river whose currents are shaped by both mountains and canyons in the fabric of space. What other invisible landscapes are guiding our journey through the cosmos? This cosmic push and pull, a grand dance of voids and clusters, unfolds over billions of years. Yet a far more intimate and unsettling possibility emerges from the realm of pure chance. Imagine the entire history of our universe, from the Big Bang to the formation of galaxies, our solar system, and the slow, intricate evolution of life leading to your own conscious mind. According to one nightmarish thought experiment, it is statistically more probable that all of this is an illusion. This is the Boltzmann brain paradox. It springs from the deep connection between entropy, which is the measure of disorder in a system, and the arrow of time. The universe as we see it is in a state of incredibly low entropy, a highly ordered and unlikely state compared to the featureless heat death that awaits in the far future. In a vast, eternal, and random cosmos, fluctuations are inevitable. Given enough time, even the most improbable events will occur by random chance. A fully formed, self-aware brain, complete with all its memories and sensory experiences, could spontaneously pop into existence from the quantum foam of empty space. This brain would find itself seemingly in a body, in a world, with a past it remembers but that never actually happened. The paradox is this: in an infinite universe, the number of such lone, disembodied brains hallucinating a cosmos would vastly outnumber the number of real, evolved brains in a genuine 14-billion-year-old universe. The odds, purely from a statistical standpoint, favor you being one of these phantom minds, a momentary glitch in the void, rather than a product of a long and ordered cosmic history. This is not a theory anyone believes is true, but a profound philosophical puzzle. It forces us to question the very nature of our consciousness and the patterns we perceive. Is our sense of a continuous, real past just a convincing fiction generated by a random fluctuation? The paradox suggests that our most fundamental assumption, that our memories reflect real events, might be the greatest pattern of all, and one that could be written in sand, destined to vanish without a trace. The statistical nightmare of the Boltzmann brain forces us to question the very fabric of our experience. Yet there is another, equally unsettling idea that flips this puzzle on its head. What if our reality is not a random fluctuation, but a deliberate construction? This is the simulation hypothesis, the provocative theory that our entire universe, with all its galaxies, life, and conscious minds, is nothing more than an incredibly sophisticated computer simulation, a cosmic video game running on some advanced civilization's hardware. The reasoning begins with a simple projection. If a civilization ever reaches a level of technological maturity, it would likely possess the vast computational power needed to run detailed simulations of its own history, or of entirely fictional worlds. And if such a civilization could run one simulation, why not run millions or even billions? If that is the case, then the number of simulated minds would quickly and vastly outnumber the number of original, base reality minds. Statistically, we are far more likely to be one of the countless simulated beings than one of the rare originals. But is there any pattern in our reality that could be evidence of this? Proponents point to the inherent mathematical elegance of the universe. The laws of physics are not a messy collection of rules. They are described by beautiful, concise equations, as if the universe were written in a clean, efficient code. Then there is the bizarre behavior of the quantum world, particularly the famous double-slit experiment. When you fire particles at a barrier with two slits, they behave like waves, creating an interference pattern. But the moment you place a detector to observe which slit a particle goes through, the wave-like behavior collapses, and the particles act like tiny bullets. It is as if the simulation is only rendering the fine details of reality when someone is looking, optimizing processing power by not calculating every single possibility all the time. These potential glitches in the matrix are not just scientific curiosities. They strike at the heart of our existence. If this is a simulation, then the hidden pattern of reality is not a law of physics, but a line of code. The search for a unified theory of everything becomes the search for the simulation's source code. The deep, philosophical questions about free will and consciousness transform into questions about programming and artificial intelligence. Are our choices our own, or are they predetermined by the algorithms of our creators? The simulation hypothesis does not offer comforting answers, but it reframes our entire quest for cosmic patterns. We may not be discovering the fundamental laws of nature, but reverse engineering the architecture of a reality that was built, not born. Deep within the abstract world of pure mathematics, a set of numbers so strange they were once dismissed as a useless curiosity may hold the master key to reality's code. These are the octonions, an 8-dimensional number system where the normal rules of arithmetic break down. Unlike the numbers we use every day, or even the complex numbers used in quantum physics, multiplying octonions is non-associative. This means that if you multiply 3 octonions together, the answer you get depends on which pair you multiply first. It is a world where the sequence of simple operations changes the outcome, a mathematical realm of fundamental unpredictability. For decades, these numbers and a related structure called the exceptional Jordan algebra were seen as beautiful but barren mathematical artifacts, with no possible connection to the real world. Then, theoretical physicists began to notice something startling. The unique properties of these exotic mathematical structures seem to perfectly mirror the behavior of the fundamental forces and particles that make up our universe. The strong nuclear force, the weak force, electromagnetism, and the specific quirks of quarks and leptons all found a natural, elegant home within the geometry of the octonions. It is as if the universe was not built on the simple numbers we learned in school, but on this far more complex and intricate numerical foundation. This discovery points to a truth more profound than any single theory. The very laws of physics, the rules that govern everything from the spin of an electron to the fusion in a star, appear to be written in the language of exceptional mathematics. The universe seems to have chosen the most beautiful, and in some ways the most peculiar possible mathematical blueprint for its own construction. Why would reality favor such an exotic and complex set of rules? It suggests that the deepest patterns are not just physical, but are ultimately mathematical in nature, waiting to be decoded in the rarefied language of numbers that most of us never see. Sometimes the simplest observations reveal the deepest mysteries. A Tanzanian student named Erasto Mpemba was making ice cream in the 1960s when he noticed something impossible. The warm milk and sugar mixture he placed directly in the freezer seemed to solidify faster than the batches he had cooled first. This defied all common sense, yet his casual observation grew into a confirmed scientific phenomenon. Hot water can, under specific conditions, freeze more quickly than cold water. This is the Mpemba effect, a baffling quirk that transforms a kitchen experiment into a profound puzzle. How could adding energy to a system make it reach a frozen state sooner? The answer appears to lie in water's secret life. Water is not a normal liquid. It is a substance brimming with anomalies that make it uniquely suited for life and for mystery. Most liquids become denser as they cool, but water reaches its maximum density at 4 degrees Celsius. Below that, it expands, which is why ice floats. This single oddity prevents lakes from freezing solid from the bottom up, preserving aquatic ecosystems. Water also has an unusually high surface tension, allowing insects to walk on it, and a tremendous capacity for storing heat, which moderates our planet's climate. These are not random traits. They are clues to a complex molecular architecture, a hidden pattern of hydrogen bonds that constantly break and reform, creating a fleeting, shifting network within the liquid. In the Mpemba effect, scientists theorize that the initial heat might actually accelerate the path to freezing. The extra energy could help break apart complex clusters of water molecules, allowing them to snap into their rigid, crystalline structure of ice more readily. Or perhaps warm water experiences more rapid evaporation, reducing the total volume that needs to freeze, and creating a cooling effect through the loss of the most energetic molecules. The very fact that there is no single, agreed upon explanation for such a simple experiment is humbling. It shows that even the most familiar substance holds layers of secrets, behaving in ways that our standard models cannot fully predict. The freezing of a single drop of water is a microcosm of phase transitions everywhere, from the sudden magnetization of a metal to the collective flocking of birds. These are complex systems poised on a knife's edge, where a small nudge can trigger a dramatic shift in state. What other hidden rules govern these sudden transformations? And what could they teach us about the universe's preference for spontaneous order? A faint, ethereal triangle of light sometimes rises from the horizon in the deep twilight, a celestial phantom visible only in the darkest, clearest skies. This is the zodiacal light, a soft glow often mistaken for the first hint of dawn, but its source is far more cosmic. It is sunlight, scattering off a colossal cloud of fine dust that fills the inner solar system, a disk of debris stretching from the sun out beyond the orbit of Mars. This is not a uniform haze. The dust is concentrated along the same flat plane in which the planets orbit, the ecliptic, tracing out the fundamental architecture of our solar system like chalk dust on a vast blackboard. The very name, zodiacal light, comes from the fact this glow appears to follow the constellations of the zodiac, the backdrop for the sun's annual journey across our sky. But where does all this dust come from? It is the perpetual fallout of celestial demolition. Comets, those icy wanderers from the outer darkness, leave behind trails of dust as they swing near the sun and partially vaporize. Asteroids, constantly colliding and grinding against each other in the belt between Mars and Jupiter, contribute their own rocky powder to this immense, swirling reservoir. The zodiacal light is the accumulated glow of countless shattered worlds and evaporated ice balls, a memorial to the violent processes that have shaped our cosmic neighborhood for billions of years. This dust cloud is not static. It is a dynamic system with individual particles spiraling inward toward the sun over time, pushed by the subtle but relentless pressure of sunlight itself. This creates a constant cycle of creation and destruction, a slow-motion rain of cosmic dust that reveals the solar system as a living, breathing, and ever-changing entity. By studying the patterns and composition of this dust, we are essentially taking a core sample of the solar system, analyzing the primordial ingredients left over from its formation. It is a hidden structure, a delicate fingerprint of our planetary system's ongoing evolution, painted in light against the canvas of the night. Beyond the orbit of Neptune lies a frozen frontier, a vast disk of icy worlds known as the Kuiper Belt. This is the solar system's attic, filled with primordial rubble left over from its construction. Astronomers expected this population of objects to continue steadily as they scanned further out into the darkness. Instead, they found a cliff. At a distance of about 50 astronomical units from the Sun, the number of Kuiper Belt objects suddenly and dramatically plummets. It is as if a cosmic gardener came through and neatly swept this region of space nearly clean. This is the Kuiper Cliff, and its existence defies every standard model of how the solar system formed. There should be a healthy population of icy bodies extending for hundreds of astronomical units. Yet beyond this invisible boundary, the vast disk of debris just stops. What force could possibly be responsible for such a sharp and unexpected edge? The most compelling theory points to the gravitational influence of a hidden world. An unseen planet, perhaps several times the mass of Earth, could be orbiting in the frozen gloom far beyond the cliff. Its gravity would act as a shepherd, clearing out a vast swath of space by either ejecting smaller objects or herding them into clustered, distant orbits. This hypothetical Planet 9 would not be a simple wanderer. Its own orbit would be strangely tilted and elongated, a ghostly signature imprinted on the chaotic dance of the icy bodies we can see. The peculiar, clustered orbits of several extreme trans-Neptunian objects all seem to point to a common source of gravitational perturbation, as if they are all being subtly tugged by the same invisible maestro. This hidden pattern in the orbital distribution of distant ice dwarfs is our best clue. We are not seeing the planet itself, but we are seeing the wake it leaves in the sea of frozen debris, the shadow it casts upon the cosmos. Finding this world would be a monumental discovery, revealing that our solar system is far larger and more complex than we ever dreamed. It would mean that for centuries, we have been living in a system with a hidden giant, a silent partner to the Sun whose presence is written only in the empty spaces and the strange paths of the most distant objects. On a quiet August night in 1977, a radio telescope in Ohio heard a whisper. For 72 seconds, a powerful narrowband signal blasted through the silence of space, so perfectly aligned with the expected signature of an intelligent transmission that the astronomer who discovered it, Jerry Amon, circled the printout data and simply wrote, "Wow." And then, just as suddenly as it arrived, the signal vanished, never to be heard again. It was a cosmic flare that burned for a moment and then went dark, leaving behind one of history's most tantalizing mysteries. The wow signal was not random noise. It was a concentrated burst of energy on a specific frequency, the hydrogen line, which scientists have long considered a logical channel for interstellar communication. It was the kind of pattern we were actively searching for, a perfect candidate for a message from the stars. Yet its fleeting, one-time nature has made it impossible to verify. A single, brilliant sentence in a conversation we cannot continue. This singular event fuels the ongoing search for more than just a signal. Scientists listening to the stars are not just hoping for another blip. They are hunting for structure, for architecture within the noise. They search for signals that repeat in a complex mathematical sequence, like the digits of pi, a pattern that could not be formed by any natural cosmic process. They look for prime number sequences, a universal language of mathematics that any technological civilization would recognize. Or they search for a signal that is modulated, carrying information within its waves, much like our own radio and television broadcasts leak into space, telling a story of the world that created them. A single, unexplained signal could be a cosmic mirage, a freak natural event we do not yet understand. But a repeating pattern, a deliberate structure, would be something else entirely. It would be a beacon of intent. Confirming such a pattern would shatter our cosmic solitude, instantly transforming the universe from a collection of silent, lifeless rocks into a neighborhood. It would mean that the hidden patterns we have been exploring are not just the impersonal laws of physics, but that one of them, the pattern of life and intelligence, is also woven into the fabric of the cosmos. The silence since that night in 1977 is not empty. It is a canvas, and we are listening, waiting for the next brushstroke to appear. This silent canvas of space holds a question so profound it threatens to unravel our understanding of reality itself. When a single speck of dust, or an entire star, crosses the boundary of a black hole, the event horizon, it vanishes from our universe forever. But what happens to the information that dust particle contained? Its atomic structure, its history, every unique detail that made it what it was. According to the ruthless rules of quantum mechanics, information can never be truly destroyed. It can be scrambled, hidden, or transformed, but it must, in principle, be recoverable. General relativity, however, paints a different picture. It describes a black hole as a place of pure, featureless gravity, where anything that falls in is crushed into a single point of infinite density, the singularity. From this perspective, the information is utterly and permanently erased. This is the black hole information paradox, a fundamental clash between our two most successful theories of the universe. For decades, physicists have wrestled with this problem, and their proposed solutions point to realities stranger than fiction. One of the most compelling ideas returns us to the holographic principle. It suggests that the information is not lost inside the black hole at all. Instead, every bit of data about what falls in is perfectly preserved, encoded in a scrambled, two-dimensional pattern on the event horizon itself. The surface of the black hole acts like a cosmic hard drive, storing a pixelated hologram of everything it consumes. The three-dimensional reality inside the black hole is just a projection of this information. But this elegant solution creates another, more violent possibility. If the information remains on the surface, what would an astronaut actually experience while crossing the event horizon? According to Einstein's equations, they would feel nothing special at first, passing through that invisible boundary without a ripple. But if the information is stored there, the horizon cannot be a peaceful place. It might be a seething, blazing wall of fire, a firewall of incredible energy that would instantly vaporize anything that touches it. This firewall would protect the integrity of the information, preventing it from being duplicated, but it would mean the event horizon is not the smooth gateway we once thought. How can two such different pictures of the same event both be true? The resolution may lie in the nature of information itself, suggesting it is the most fundamental ingredient in the universe, more basic than space or time. The hidden pattern is not written in matter or energy, but in bits, a cosmic code that ensures nothing, not even the total annihilation of a black hole, is ever truly forgotten. But what if the universe is not expanding at all? The tired light hypothesis dares to rewind the clock on our most fundamental discovery. It proposes a startling alternative to the Big Bang, suggesting that the redshift we see in distant galaxies is not caused by the stretching of space itself. Instead, this theory posits that light simply grows tired. As photons race across the cosmic void for billions of years, they might gradually lose energy through tiny, cumulative interactions with the sparse medium of interstellar space, or perhaps through some unknown physics we have yet to comprehend. This energy loss would manifest as a shift toward the red end of the spectrum, mimicking the exact same effect we attribute to universal expansion. The universe, in this view, could be static, eternal, and infinite. This idea persists on the fringes of cosmology because it offers an elegant solution to several nagging puzzles. It neatly avoids the need for a singular beginning, a Big Bang emerging from a state of infinite density that challenges our physics. It also sidesteps the necessity for dark energy, that mysterious force invoked to explain the universe's accelerating expansion. If light is merely losing energy over distance, then no mysterious anti-gravity is required. The pattern we see is not one of flight, but of fatigue. Yet for all its philosophical appeal, the tired light model faces immense observational hurdles. A simple energy loss would not produce the specific, detailed patterns we see in the light from distant supernovae. Crucially, it fails to explain why the stretching of space also causes time to dilate, an effect we clearly observe in the prolonged fading of these stellar explosions. The light from a tired universe would not show this time-stretching effect. So why does this idea endure? It represents a deep human desire for a different kind of cosmic pattern, one of stability over chaos, of a timeless cosmos without a definitive start or finish. It challenges us to prove, beyond any doubt, that the redness truly means retreat, and that the grandest hidden pattern of all is not a slow dimming, but a great and endless flight. Earth itself seems to breathe with a single living rhythm. The Gaia hypothesis proposes our planet is not just a rock hosting life, but a vast, self-regulating superorganism. The atmosphere, oceans, and geology interact in a delicate dance with the biosphere to maintain conditions perfect for life's continuity. Oxygen levels, global temperature, and ocean salinity are all held in a stable balance not by chance, but through a complex web of feedback loops involving everything from bacteria to rainforests. It is a powerful vision of a planet that actively tends its own garden. But what if this is not a unique earthly phenomenon? What if Gaia is merely a local expression of a far grander cosmic principle? Imagine extending this idea to the universe itself. The fundamental constants and laws of physics appear fixed and unchanging, the rigid rules of reality. But what if they, too, are part of a slow cosmic dance? Some speculative theories suggest these laws might not be immutable. Perhaps they evolve, shifting subtly over billions of years in a direction that inherently favors the emergence of complexity and, ultimately, consciousness. This is cosmic biophilia, the idea that the universe has a built-in bias for life. Instead of a cold, random cosmos where life is a freak accident, the universe might be predisposed to create the conditions necessary for its own self-awareness. The fine-tuning of the constants would not be a lucky roll of the dice in a multiverse casino, but the result of a deep evolutionary process. The cosmos learns, adapts, and complexifies, with the laws of physics themselves evolving to support richer and more intricate structures. In this view, a star is not just a fusion reactor. It is a crucible forging the elements for future planets and living beings. A galaxy is not just a collection of stars. It is a vast ecosystem, its spiral arms churning and mixing the ingredients of life across cosmic distances. The universe becomes less like a machine and more like a living, breathing entity, one whose ultimate pattern is the slow, patient cultivation of mind. Are we merely inhabitants of this cosmos, or are we the universe itself beginning to wake up and look back at its own astonishing creation? That same cold spot in the cosmic background radiation, a chill in the ancient sky, might have a source closer to home in time and space. Lying in the direction of the constellation, Boötes is one of the largest structures ever identified, a cosmic desert of staggering proportions known as the Boötes supervoid. This is not merely an empty patch. It is a spherical region of space over 300 million light-years across that is profoundly, unnervingly empty. While space is filled with the vast cosmic web, the Boötes supervoid is a gaping hole in that web, a place where galaxies are almost entirely absent. If you were at the center of this void, you would look out into a near total blackness, with only a handful of faint, lonely galaxies visible in an ocean of night. Such immense voids are part of the cosmic web's natural structure, but the Boötes supervoid is an extreme outlier, a grand canyon so deep and wide it challenges our understanding of how the universe evolved. Its sheer size is the problem. According to standard cosmology, a void this vast should not exist. The universe did not have enough time, in its 14 billion year history, for gravity to clear out such an immense volume of matter. It is a statistical anomaly on a cosmic scale, and this is where the mystery deepens. The Boötes supervoid lies in the same direction as the cold spot, that unusually cold region in the cosmic microwave background. Could the two be connected? One compelling explanation involves a phenomenon known as the integrated Sachs-Wolf effect. As light from the cosmic microwave background travels through the universe, it climbs in and out of gravitational wells created by clusters of galaxies and voids. When light enters a gravitational well, it gains energy, appearing slightly hotter. When it climbs out, it loses energy, appearing cooler. Normally, these effects cancel each other out over a long journey. But if light passes through a gigantic, evolving void like the one in Boötes, the story changes. The void's gravitational pull weakens over time as the universe expands. A photon entering the void loses more energy climbing out than it gained falling in, resulting in a net loss of energy, a cooling of the light. In essence, the supervoid acts as a cosmic hill, and light rolling down the other side is permanently tired, leaving a cold imprint on the sky. This is an elegant, physical explanation that ties two mysteries into one. Yet, the numbers are stubborn. The observed cold spot is so large and so cold that even the immense Boötes supervoid may not be sufficient to explain it. The cooling effect should be much smaller than what we actually observe. This discrepancy opens the door to a far more radical idea. What if the cold spot is not a shadow cast by a void, but a bruise left by a primordial collision? Some cosmologists propose that our universe, in its earliest moments of inflationary expansion, might have bumped into another universe, a separate bubble in the vast multiverse. Such a cosmic fender bender would have deposited a tremendous amount of energy into a localized region of our cosmos. As that region expanded and cooled, it would have left behind a specific signature, a circular patch of unusual cold, exactly like the one we see. In this breathtaking scenario, the cold spot is not a flaw in the data, but our first tentative piece of evidence for a cosmos beyond our own, a scar on the skin of our reality from a contact with another world entirely. Is the Boötes supervoid a natural, if extreme, part of our universe's architecture? Or is it the aftermath of a crash, the echo of a collision with another universe in the infinite multiverse? This delicate blueprint for all cosmic structure was written in an unimaginably brief flash of creation. In the first tiny fraction of a second, the universe underwent a period of hyper-accelerated expansion known as inflation, stretching a subatomic speck of space into a cosmos larger than our observable horizon. During this violent stretching, the quantum foam that constitutes spacetime itself was magnified to a macroscopic scale. Tiny, random fluctuations in energy and density were blown up to enormous sizes, frozen into the fabric of the expanding universe as a specific pattern of ripples. This pattern is known as the Harrison-Zeldovich spectrum, and it is the primordial power spectrum. It describes the initial distribution of these density ripples, the subtle hills and valleys in the gravitational landscape of the infant cosmos. What makes this pattern so special is that it is nearly scale invariant. This means the relative amplitude of the fluctuations, their hills compared to their valleys, is roughly the same regardless of the size of the region you examine. Whether you look at a patch of space that will one day become a single galaxy or a massive supercluster of thousands of galaxies, the initial variations in density were proportionally identical. It was a cosmic rule that applied equally to the small and the large, a democratic seed for all future structure. Without this specific, finely tuned pattern, our universe would look utterly different. If the fluctuations had been much stronger, matter would have collapsed too quickly, forming only enormous, black hole-dominated monstrosities. If they had been much weaker, gravity would never have overcome the expansion of the universe, and no stars or galaxies would have ever formed at all. We exist because the seeds were planted with just the right strength. These infinitesimal wrinkles were the universe's only initial instruction. From them, gravity did the rest, patiently amplifying these slight overdensities over billions of years. A tiny region with just a little more dark matter would exert a slightly stronger gravitational pull, slowly drawing in more and more material from its surroundings. This process of accretion snowballed over cosmic time, with the small seeds growing into the first stars, then galaxies, and finally the vast, interconnected filaments of the cosmic web. The great walls of galaxies and the profound emptiness of the voids are all the adult versions of those infant whispers. Every structure you see in the night sky, every cluster and supercluster, is a direct descendant of a specific ripple in the Harrison-Zeldovich spectrum. This hidden pattern is the ultimate origin of cosmic architecture, the fundamental signature of inflation, and the reason we are here to trace its lines across the sky. Deep within the abstract architecture of mathematics lies a structure of breathtaking symmetry, a pattern in 248 dimensions known as the E8 Lie group. To even picture it is a challenge for the human mind, a complex, multi-dimensional shape where every point represents a unique symmetry. This is not just an esoteric curiosity. Some physicists believe this intricate geometric object could be the ultimate source code for our universe, a single mathematical pattern from which all particles and forces emerge. The appeal is profound. In our current standard model, the fundamental particles and forces are a bit of a jumbled collection, like finding separate pieces of a puzzle without knowing what the final picture should be. The strong nuclear force, the weak force, electromagnetism, and the different families of quarks and leptons all operate under their own distinct rules and symmetries. A grand unified theory seeks to show that these are all just different facets of a single underlying symmetry that was manifest in the high-energy forge of the Big Bang. The E8 group is a candidate for that master symmetry. Its 248-dimensional structure has just the right mathematical properties to contain the symmetries of all known particles and forces within its elegant geometry. In 2007, physicist Garrett Lissy presented his an exceptionally simple theory of everything, which proposed that each known particle could be mapped directly onto a specific point in the E8 pattern. In this vision, an electron, a quark, or a photon is not a separate entity, but merely a manifestation of a specific symmetry within this grand, cosmic shape. The dance of the universe would be the natural unfolding of E8's geometry. The gravitational force, which has stubbornly resisted inclusion in other unification attempts, also finds a potential home here, woven into the same tapestry as the other forces. This is the dream of physics, to find a single, beautiful equation that describes everything. Yet the path from this sublime mathematical beauty to the messy reality we observe is fraught with challenges. The primary hurdle is connecting this perfect, 8-dimensional symmetry to our familiar 4 dimensions of space and time. How does the complex geometry of E8 break down to produce the specific particles and forces we see, with their particular masses and charges? So far, no version of the theory has successfully made predictions that can be tested with our current particle accelerators. The mathematics is profoundly beautiful, but is it physics? The struggle with E8 highlights a deeper tension in our search for cosmic patterns. We are drawn to elegance and simplicity, believing the universe's fundamental laws must be beautiful. Yet we are forced to test our beautiful ideas against a reality that can be stubbornly complex and asymmetrical. Does this mean the theory is wrong, or that we have not yet learned to read the full message written in this exquisite, hidden code? Our own galactic journey is just a single current in a far greater river. Astronomers have mapped the motion of thousands of galaxy clusters, and they have found something that defies all conventional explanation. These immense structures, each containing thousands of galaxies, are not just moving apart with the general expansion of the universe. They are also streaming together in a specific, common direction at a staggering speed of over 600 kilometers per second. This coordinated motion is known as the dark flow. It is as if a cosmic wind is blowing, pushing entire superclusters of galaxies on a course that cannot be accounted for by any visible matter. The gravitational pull from every known galaxy, cluster, and filament of the cosmic web has been meticulously calculated. Yet, the force required to produce this dark flow is immense, and it points to a source that lies beyond the edge of everything we can see. The most haunting explanation is that this river of galaxies is being pulled by something outside our observable universe. The Big Bang did not create everything that exists, only everything we can possibly see. Beyond our cosmic horizon, there may be regions of space-time that inflated differently, containing vast, unseen structures of matter. Imagine our universe as a bubble in an infinite foam. The gravitational pull from a neighboring bubble, a supermassive structure just over the horizon, could be tugging on everything inside our own bubble. We cannot see this external attractor, just as a ship in a fog bank cannot see the massive waterfall that pulls the current. But we feel its pull. We see its effect on the motion of galaxies. This dark flow suggests that the grand structure of reality is far larger and more complex than we ever imagined, and that our entire observable cosmos may be just one small piece in an infinite, structured mosaic. What immense landscapes lie beyond the veil of our perception, their gravity reaching across the void to guide us. A star does not always die with a quiet fate. In 2002, A faint, anonymous star in the constellation Monoceros erupted with a violence that defied all known categories. V838 Monocerotes, a star previously too dim for most catalogs, flared with the fury of a million suns, becoming for a brief moment the brightest star in our entire Milky Way. This was not a supernova, the final, self-destructive blast of a giant star. It was something new, something strange, a stellar phenomenon so rare it forced astronomers to rewrite their textbooks. They called it a luminous red nova. The pattern of its brightening was the key. It did not explode once and then fade. It pulsed, flaring to a peak, then fading slightly, only to flare again even brighter in a series of distinct, violent outbursts over several months. This rhythmic, step-like eruption was a signature of a hidden stellar process, a metamorphosis happening in real time. The prevailing theory points to a cosmic dance of death and rebirth. The 838 Monocerotes was likely not a single star, but a binary system, two stars locked in a close gravitational embrace. Over millennia, the larger star began to swell, and its outer layers were siphoned off by its smaller, denser companion. This transfer of mass is a delicate balancing act. Eventually, the smaller, thieving star became so bloated and unstable that it could no longer hold onto its stolen atmosphere. In a cataclysmic reversal, this immense shell of hydrogen gas fell back on the primary star. The energy of that infalling gas, slamming into the star's surface at incredible speeds, triggered the series of thermonuclear explosions we witnessed as the Great Outburst. The result was not destruction, but transformation. The star did not die. Instead, it was reborn, inflating at a breathtaking rate to become a supergiant thousands of times larger than our own sun, its surface cooling to a deep, luminous red. The hidden pattern here is one of stellar evolution taking a forbidden path. We thought we had a simple chart. A star is born, it lives on the main sequence, and then it dies as a white dwarf, a neutron star, or a black hole. The 838 Monocerotes revealed a secret shortcut, a dramatic detour where stars can merge, erupt, and be utterly transfigured, skipping entire stages of their predicted life cycle. What other stellar secrets are written in the rare, violent flashes that punctuate the darkness? Even the heart of the atom holds patterns we thought we understood. Deep within the nucleus, protons and neutrons arrange themselves in shells, much like the orbits of electrons around the atom. Certain numbers of these particles create exceptionally stable configurations, numbers that physicists call the nuclear magic numbers. 2, 8, 20, 28, 50, 82, and 126. These are the numbers that grant atomic nuclei their greatest stability, the bedrock of nuclear physics. But what if a new, impossible form of matter could rewrite this magical list? Enter the tetraneutron, a hypothetical and profoundly strange particle, a stable cluster of 4 neutrons and nothing else. A nucleus with 4 neutrons should be fundamentally impossible. The strong nuclear force, which glues protons and neutrons together, is incredibly short-ranged and works best in proton-neutron pairs. A group of neutrons alone, with no protons to bind them, should fly apart in an instant. The very idea defies the established rules of the nuclear dance. Yet, in recent experiments, scientists believe they may have glimpsed this phantom. By firing a beam of helium-8 nuclei at a target, they created a momentary resonance, a flicker of something that looked exactly like a tetraneutron, existing for just a billionth of a second before it vanished. That fleeting existence is the revolution. If confirmed, the tetraneutron would shatter our current model of nuclear forces. It would mean that the strong force can act in ways we never predicted, creating bonds where none should exist. This would force us to reconsider the very magic numbers that define nuclear stability. Perhaps there are new, hidden shells, new patterns of stability waiting to be discovered within the nucleus. The tetraneutron is not just a new particle. It is a key that could unlock a hidden door in the nuclear chart, revealing a new layer of structure and pattern in the fundamental forces that build our reality. What other secrets are woven into the fabric of the atom, waiting for the right experiment to bring them into the light? The universe should be teeming with voices. With countless stars and even more planets, the silence from the cosmos is a profound and unsettling pattern in its own right. This is the core of the Fermi paradox, the stark contradiction between the high probability of alien civilizations and the total lack of any evidence for them. If life is a natural outcome of cosmic evolution, then where is everybody? The unsettling answer may lie in a hidden filter, a barrier so great that almost no civilization survives it. This is the Great Filter Hypothesis, a pattern of cosmic extinction. Perhaps the filter lies in our past. The leap from non-living chemistry to the first self-replicating cell might be so astronomically rare that we are the only ones to have crossed that chasm. Or maybe the filter is something we have already passed, like the development of complex multicellular life. The more terrifying possibility is that the great filter awaits us in our future. It could be that all technological civilizations inevitably discover the means of their own destruction, whether through nuclear war, engineered pandemics, or a runaway artificial intelligence. The silence would then be a graveyard, a pattern of civilizations that bloomed and then vanished. But there are other, less grim patterns that could explain the quiet. The zoo hypothesis suggests that advanced civilizations know we are here, but are deliberately avoiding contact, observing us as we would a protected nature preserve. They are waiting for us to reach a certain level of maturity before introducing themselves, preserving the natural development of a young species. Alternatively, the universe might be filled with life, but it is so alien, so different from anything we can conceive, that we simply do not recognize its signals. Their technology or their very mode of existence might be indistinguishable from the natural background of pulsars and nebulae. Their conversations could be happening all around us, written in a language of physics we have not yet learned to read. This great silence is not an empty void. It is a message. It tells us that the pattern of life and intelligence is either incredibly fragile, incredibly rare, or so advanced that it has transcended the noisy, visible phase we are currently in. The quiet forces us to look inward, to consider our own future, and to ask if the ultimate hidden pattern is one of solitude or simply one of patience. This relentless cosmic silence may be the prelude to a final, violent crescendo. Our journey through hidden patterns now brings us to the most extreme fate imaginable, a destiny written not in the birth of stars, but in their ultimate annihilation. The universe's expansion is not just accelerating, it is driven by a mysterious force we call dark energy. But what if this force has a more potent and terrifying variant? This is phantom energy, a hypothetical form of dark energy with a truly monstrous property. Its repulsive force would not remain constant, but would grow stronger over time, becoming infinitely powerful. The pattern this creates is one of inevitable total destruction, a hidden countdown to an event cosmologists call the Big Rip. Imagine the expansion of space itself turning from a steady tide into a raging tsunami. First, the phantom energy's strengthening grip would overcome the gravitational glue holding galaxy clusters together. These vast cities of stars would be flung apart in the ever-widening void, each galaxy becoming a lonely, isolated island. Next, the force would target individual galaxies. The Milky Way and all the stars within it would be torn asunder. Our solar system would be ripped from its galactic moorings and sent careening into the blackness. But the horror would not stop there. As the phantom energy intensifies, it would eventually overwhelm the forces that hold solar systems together. The sun's gravity would no longer be enough to keep Earth in its orbit. Our planet would be flung away from its life-giving star, destined to freeze in the interstellar deep. Then it would come for our world itself. The subtle gravitational pull that holds Earth together would be vanquished. Mountains, continents, and oceans would be lifted from the planet's core and scattered into space. Finally, in the last fleeting moments, the phantom energy would attack the very fabric of reality. It would exceed the strength of the forces that bind atoms together. Every molecule, every atom, every atomic nucleus, and the electrons orbiting it would be violently ripped apart. The universe would end not with a crunch or a fade, but with a final, silent scream as every last bit of structure, every hidden pattern we have ever traced, is dissolved into a thin, cold haze of fundamental particles, forever isolated and unable to ever interact again. This is the ultimate hidden pattern, a signature of dissolution written into the dark energy that may even now be gathering its strength. Is this the final, terrifying truth behind the universe's accelerating flight? A pattern of cosmic suicide encoded in the vacuum of space itself. From the spiral of a galaxy to the phantom tug on a distant spacecraft, these 30 theories paint a portrait of a cosmos whispering with intelligence. We have traced the golden ratio in a seashell and in the spin of a quasar. We have stood at the edge of a black hole and questioned the nature of information itself. Each mystery, from the fine-tuned constants to the great cosmic silence, reveals a universe that is not random chaos, but a tapestry of profound and intricate order. This relentless human drive to find patterns, to decode the hidden language of reality, is perhaps the most telling pattern of all. It speaks to our deep-seated need to understand our place in this vast, beautiful, and often bewildering existence. We are the universe beginning to comprehend itself. So the next time you find yourself under a clear night sky, remember these threads of connection woven through the darkness. Look up and feel the wonder of it all, and tell us which of these hidden patterns resonates most deeply with you. Share your favorite theory in the comments below, and let's continue this cosmic conversation together.